Okay, so we're going to pick up at section 3.2.0 of the NCCER Millwright Level 2 Module 6 Rigging Module, starting on page 12. They talk about, you learned about inspecting of slings during the core curriculum module, which we did. We're going to be doing some sling inspections out in the shop, and here's some more information, and they go into a little more detail on some of these than they did before. But some general guidelines with any type. Store slings in a rack to keep them off the ground. And the rack should be in an area free of moisture and free of any acid or damaging fumes. Again, the moisture to stop corrosion, rust, chains, wire ropes, metal mesh. Acid fumes will attack all the metals, will attack the synthetics. Store them inside so the synthetics don't get damaged by UV rays, things like that. Never let slings lie on the ground in areas where machinery can run over them. That's going to smash, damage, crush, whatever word you want to use on all of those. And then slings should be inspected at each use. Every time we use a sling, we have to inspect it. And they say for broken wires, kinks, rust, or damaged fittings. Any slings found to be defective should be destroyed. And we talked about that. Cut the eye out on something like this or something like this so they can't be used. With this one, we can just cut it apart. But again, with these, cut the eye out so people can't use them. Okay? Now we're going to get into each individual one. Wire rope slings is what they start with. And they should be destroyed if you discover any of the following conditions. Broken wires. Remove a wire rope sling from service. You find 10 randomly distributed broken wires in one rope lay. Remember, the one rope lay is where it starts here and the distance it takes to go around here and make one revolution. So 10 broken wires in that area together there is reason to get rid of it. Or 5 broken wires in one strand. So if there's 5 broken wires in that one strand going around there, that means it's time to get rid of it also. The next one is a little confusing. Diameter reduction. Now, it says some wear is normal. However, if the wear exceeds 1/3 of the original diameter, that's when it has to be thrown away. If you get wear on this, most people are going to throw it away a long time before 1/3 of it is worn away. But that is the standard. So there are places out there that are going to say, no, that's still safe to use until 1/3 of it's gone. So what we do is we measure the distance, the diameter of the choker, or we look at the tag and get the diameter of the choker or sling, and we measure it with not with a tape measure, but like a caliper or something like that. That's going to give us measurements in thousandths of an inch, and this one's a 1/4 inch choker. So we would take 250 thousandths times, because the decimal equivalent of 1/4 inch is 250 thousandths, times 33% or 0.33, we would be able to lose 82 thousandths off of here. So if we take 2.250 minus 0.082, this could be 168 thousandths. In theory, that's a little over 1/8 of an inch is going to be 125. Another half of that would be 60 thousandths, which would be a 1/16. This would be about 3/16 of an inch thick before we could technically, according to the standard, get rid of it. Heat damage, we're going to see burn marks. We're going to see discoloration. Corrosion, rust. Rust on the outside is bad, but rust on the inside is very, very hard to detect. If we see any rust in these, it's usually a good indication to start getting rid of it. Damaged end fittings, that's going to be obviously the eyes. Any sort of damage to these thimbles that hold it in there, any sort of damage like these are crushed down. They should be open more, so these would fail. Next one is rope distortion. We've seen that in the core, the kinking. There would be not a bad kink, but it started of a kink. Crushing and bird caging. Crushing when something got set down on and smashed it. Bird caging kind of when it opened up, when this pushed together and opened up and you could see the core. So that's a real bad one you got to get rid of. Core protrusion, if that core is sticking out somewhere through here, through the outer layer. And then the last one would be the unlaying of a splice. The unlaying of a splice is if we didn't have the thimbles here and they tied it back together, and if it was coming undone. That would be unraveling of a splice. The last thing, and like it said in the core, the first thing to always check, for example, there's no tag on this one, so what is it rated to lift? Right there, we would throw it away before we found any other problems with it. So that's the wire rope. Next, they do the synthetic web and round slings. The difference? Web is going to have a splice where it's sewn together, whereas the round slings are just going to be this. Web slings are eye to eye. Round slings are the continuous or loop. Okay? Basically doing the same thing with both of them, but there's a couple differences. Acid or caustic burns. Obviously, any sort of damage from acid or caustic, we're going to get rid of either one. Melting or charring any part of the sling, that can happen to either one of them also. We can get rid of it there. Holes, cuts, tears, snags, sure. You know, these are obvious ones. Broken or worn stitching in the load-bearing splices. Here's the load-bearing splice, if you can see it from the side, where the two pieces come together. We look at the back side there, any of the stitching coming out. Now there are some frayed pieces here, but that's where the strings, when they sewed it together, end. Actually, this one's in the splice, and this one's past the splice. But I wouldn't throw this away just because of those two. What they're talking about is damage more in here that's going to pull apart. Excessive abrasive wear to the point where the colored yarns are showing. That was the red you're dead back in here, where if we see those red fibers going across there. Knots in any part of the sling. If somebody took this and tied a knot in it to shorten it, that is going to change our angle and it's going to damage it, and we're not going to use it. Excessive pitting or corrosion or cracked, distorted, or broken fittings. Any sort of damage in the fittings is going to take that away. And like I said in the core when we were talking the other day, the easiest way to check for UV damage while we're looking at the eye is pull this apart like that. Look at the yellow color there, how bright it is. Compare it to the other. This one is not UV damage, it's just dirty. There's a difference between the two. Any visible damage that causes doubt as to the strength of the sling, that's going to be another reason to say this one doesn't get used. And then a missing or illegible tag. Here's the tag on this one. I don't know if you guys can read it or not, but your weights are going to be listed around here. And that's got to be readable like we talked with all the other ones. So with that, it brings us to the metal mesh. The metal mesh sling, the inspection of it. They can withstand a lot of abrasive, hot loads, damage, but they're still vulnerable, and we still have to inspect them every time we use them. So the first thing is a broken, welded, or brazed joint along the sling edge. They're going to be talking about these here. We're going to be looking for any damage there. It's just like one of these slings here. If we have a cut from the side, as we pull on it, it's going to pull apart. Same way with this. If we have a broken or unwelded, broken weld there, it's going to pull it apart as we pull the load against it. Remember how we talked about the 1/3 diameter of the wire rope? This one is a reduction of wire diameter of 25%, 1/4, due to abrasion. That means rubbing on here, and we've worn out one of these wires by 1/4. Again, that's the standard. If you see any wear on here, most of the time people are going to get rid of it long before 25% ever comes into play. A broken wire in any of this mesh means it's gone, because it's just like a bolt and a nut. We have to have full thread contact in between all of them. If we have one broken wire, that starts the chain effect of things breaking. And we're putting more stress on everything else, and it's designed to work all together. Lack of flexibility due to distortion of the mesh. If this is no longer flexible, if it won't bend around stuff, that's a reason to get rid of it. Distortion of the choker fitting so that the depth of the slot is increased by 10%. So if this has been damaged and this has been pulled and opened up and bent and not, 10% So we would start by taking a measurement and know the measurement that it started with, brand new, and then we would check it on a regular basis. There again, you're going to see that damage. You're going to see some of that, and it's going to be easier to detect. Distortion of either end fitting so that the width of the eye opening is decreased by more than 10%. So if either of these eyes get stretched, pulled, then it's going to change the opening, and that's the 10% they're talking about there. And then a 15% reduction in the original cross-section area of metal at any point around. If this gets reduced width-wise, anywhere here, if it gets stretched to 15% reduction from what the overall width was, or the eyes, there again, it's in. The last thing I needed to show you that I should have showed you before, but I forgot. I don't know how well you can see this on the video, and it's probably backwards, but here's your choker rating, here's your basket rating. There's your tag on these. On the other side, it gives you the length and the information and stuff like that. So, but there's your tag that you're going to base if it is the right size to use for the weight that you're trying to lift. So that's sections 3.1 and 3.2. We'll come back and discuss chain slings.